Good morning, class. Today we're going over lesson 1.8, how to use powers of 10 to estimate quantities. So let's start with estimating very large quantities here. So we can use powers of 10 to estimate large quantities. We can do this if we write them in a format that is easier to compare. So let's compare, for example, the estimated population of China. So the estimated population of China is 1,402,941,487. So the way we can write this by a power of 10 is we can find out what power of 10 we are going to need to multiply by this here. So if we count the decimal spaces, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 before we get right before the 1 here. You always want to stop right before you get to the final digit. So this would be a 1, since the 1 was the number in our last decimal place, times 10 to the power of however many digits we had. Remember, there was 9 digits, right? So this would be a 1 times 10 to the 9th. Now, if we were to actually write this out here, this would be a 1 followed by 9 zeros after it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the way we would estimate that population there. So we can use powers of 10s to estimate quantities. It's especially simple when they are larger quantities because you simply need to count the number of digit spaces. Here there were 9. And then multiply the first digit, in this case it was a 1, by a power of 10 to the 9th, since there's 9 digit places. Okay, so for our key concept today, you can estimate a very large or very small number by rounding the number to its greater place value and then writing that number as a single digit as a power of 10. So for very large numbers, for example here, you would first check and see what is in the first place here. Since this is a 3 and their number following it is a 5, we would know that we are going to round this up here. So we would round it up to 4 billion, looks like. Then you need to count the number of zeros. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. So you would multiply by 10 to the 9th. For very small numbers, it's the same thing, just backwards here. So you would need to first round it to the nearest digit here. Here we have a 2, and what follows behind it is a 3, 5. So we would just round it to 2. Then we need to count how many zeros we have. We have 1, 2, 3, 4, 5, 6, 7. So we need to multiply it by a power of 7. However, since this is a small number and we are moving in the opposite direction this time, we need to make it a negative 7 instead of a positive 7. And then you simply multiply by the digit times 10 to that power of 7. All right, so let's do some examples here. First, we have the number 1,234,567. So we need to first look at this digit right here. This right here is a 1, and then the digit immediately following it is a 2. So since this is below a 5, we are not going to round up. We are just going to leave this number at 1 million. Okay, now we got to count how many zeros we have here. I count that we have 1, 2, 3, 4, 5, 6 zeros. So that means we are going to be multiplying by 10 to the power of 6. And then we look at our number in front. It is a 1, so we need to be doing 1 times 10 to the 6. And that would be how we estimate that number there. So it's very simple. You just have to find your first number, see if you need to round, count the zeros, and then multiply by a 10 to that power. Okay, next one here. A bacteria has a diameter of 0.00000025691 meters. Write this number using a power of 10 to estimate it. Okay, so let's start with our number here. We have a 0.12345 zeros and then 25691. So remember, we need to look at this number here and see if we need to round. So we have a 2 followed by a 5, a 2 followed by a 5. So since that number is 5 and above, we need to round up, which means I can round this to 0.6 zeros followed by a 3, since we need to round up there. Okay, next thing we need to do is we need to count how many zeros we have. Here I have 1, 2, 3, 4, 5, 6 zeros. So when I'm multiplying by a power of 10, that is where this exponent is going to come from. It's going to come from however many zeros we have here. And then simply the number I have to be multiplying that power of 10 by is our last number right here, which is a 3. So we would do 3 to the power of 10 to the negative 6. The reason it is negative is because we counted backwards here. So since we went backwards, we would need to have a negative number. Because if we were to multiply this, then we would move this decimal place 6 spots to the left, and we would get 0.000000. Yep, 0.06. Alrighty, so let's do one more example here. So we want to compare the numbers 6 times 10 to the negative 6 and 2 times 10 to the negative 8. So first things it's asking us is which number has greater value. So you might be confused here a little bit, but what we need to do for the greater value is we need to look at the exponents. So if I were to write this one out here, 6 times 10 to the negative 6, I would start with my 6 here, and then I would move my decimal 1, 2, 3, 4, 5, 6 spots to the left. Whereas with my other one here, we have a 2 times 10 to the negative 8. So this would be 2 with my decimal space moved 1, 2, 3, 4, 5, 6, 7, 8 spots to the left. So if we're comparing these two numbers here, look how many more zeros this 2 times 10 to the negative 8 has here, right? So since that has much more zeros, or this exponent is much higher than this one right here, that means the number that has greater value is going to be the 6 times 10 to the negative 6. Because this exponent right here is much closer to 0 than this one is. All right, so which number has lesser value? Well, if that one has greater value, then it would only make sense that the other one has lesser value. And then how many times greater is the other number? Well, since we're moving by 2, so the difference between 10 to the negative 6 and 10 to the negative 8, the way we would find that here is we would do a 8 minus 6, or negative 8 minus negative 6, or whatever, 8 minus 6 here. We're just going to subtract the exponents. So 8 minus 6 is 2. And then we have to look how much larger is 2 times, there's 6 and 2. So 2 times 3 is going to equal 6, or I guess I could write that as 6 divided by 2. So to find out how many greater this is, this would be 3 times 2, which is equal to 6. It would be 6 times greater. All right, so make sure we're writing a conclusion today. Today we learned about estimating small numbers and estimating large numbers. So make sure you guys get a 2-sentence conclusion down here. Hope this helped you all out. I will see you all in class tomorrow. Peace out, y'all.